What is the Java Collections Framework?
The Java Collections Framework is a set of classes and interfaces that helps us store, manage, and process groups of objects efficiently. Instead of creating our own data structures, Java provides ready-made implementations like ArrayList, LinkedList, HashSet, HashMap, TreeSet, and many more. It also provides common operations such as adding, removing, searching, sorting, and iterating over elements. Think of it like a toolbox where every tool is designed for a specific purpose. If you need fast searching, use HashMap. If you need ordered data, use TreeMap. If you need duplicate values, use List. If you don't want duplicates, use Set. Choosing the correct collection improves both performance and readability.
What is the difference between collection and collections?
Many candidates get confused between collection and collections. Collection is an interface. It is the root interface of list, set, and queue. Collections is a utility class. It contains static methods like sort, reverse, shuffle, max, min, binary search, and synchronized collection. Remember it this way. Collection stores data. Collections performs operations on data.
What is the difference between list and set?
List allows duplicate elements. Set does not allow duplicate elements. List maintains insertion order. HashSet does not guarantee order. TreeSet keeps elements sorted. List allows accessing elements using an index. Set does not support index-based access. Use list when duplicate values are acceptable. Use set when uniqueness is important.
What is the difference between ArrayList and LinkedList?
ArrayList uses a dynamic array internally. LinkedList uses a doubly linked list. ArrayList provides faster random access because elements are stored continuously. LinkedList provides faster insertion and deletion in the middle because only node references change. If your application reads data frequently, use ArrayList. If it performs many insertions and deletions, LinkedList can be a better choice.
Why is ArrayList faster than LinkedList for searching?
ArrayList stores elements in contiguous memory. Using an index, Java can directly calculate the memory location. This makes access very fast. LinkedList stores elements as separate nodes. To reach the 100th element, Java has to travel through previous nodes one by one. Therefore, searching in LinkedList is slower.
Can ArrayList store duplicate values?
Yes, ArrayList allows duplicate elements. It also allows multiple null values. Example, list string, list equals new ArrayList, list add, list add, list add, list add, system out, println output.
Why is HashSet faster than ArrayList for searching?
HashSet internally uses hashing. When you search for an element, Java calculates its hash value and directly jumps to the correct bucket. ArrayList searches one element after another. So for large data, HashSet is much faster. This is why HashSet is commonly used for fast lookups.
Why does HashSet not allow duplicate values?
HashSet checks the hash code and equals methods before inserting an object. If another object with the same hash and equal value already exists, the new object is ignored. Example, set integer set equals new hash set add, system out, println output.
What is the difference between HashSet and TreeSet?
HashSet stores elements in no particular order. TreeSet automatically sorts elements. HashSet is generally faster. TreeSet is slower because it maintains sorted order using a red-black tree. Use HashSet when order is not important. Use TreeSet when sorted data is required.
What is the difference between HashMap and Hashtable?
HashMap is not synchronized. Hashtable is synchronized. HashMap is faster because there is no synchronization overhead. HashMap allows one null key and multiple null values. Hashtable does not allow null keys or null values. Today, HashMap is preferred in most applications.
What is the difference between HashMap and TreeMap?
HashMap stores data without any order. TreeMap stores keys in sorted order. HashMap uses a hash table. TreeMap uses a red-black tree. HashMap gives better performance. TreeMap should be used when sorted keys are required.
Can HashMap have duplicate keys?
No, HashMap does not allow duplicate keys. If you insert the same key again, the old value gets replaced. Example, map integer string map equals new HashMap, map put, system out println output 1 equals spring.
Can HashMap have duplicate values?
Yes, only keys must be unique. Values can be duplicated. Example, map integer string map equals new HashMap, map put, system out println output 1 equals Java, 2 equals Java.
Why are keys in HashMap immutable?
Keys should ideally be immutable. If a key changes after insertion, its hash code also changes. HashMap will not be able to find the object in the expected bucket. This may result in lookup failures. That is why string is commonly used as a HashMap key.
Why does string make a good HashMap key?
String is immutable. Its hash code never changes after creation. It also correctly implements equals and hash code. This makes searching reliable and efficient. Therefore, string is one of the best choices for HashMap keys.
What is load factor in HashMap?
Load factor determines when HashMap should increase its capacity. The default load factor is 0.75. This means when 75% of buckets are filled, HashMap automatically resizes itself. Resizing improves performance by reducing collisions.
What is the default initial capacity of HashMap?
The default initial capacity is 16 buckets. When the threshold based on the load factor is reached, the capacity becomes 32, then 64, and so on.
What is hashing?
Hashing is a technique that converts an object into a numeric value called a hash code. Java uses this hash code to determine where the object should be stored. Hashing helps achieve very fast insertion, deletion, and searching.
What is a hash collision?
A collision happens when two different objects produce the same hash code. HashMap stores both objects in the same bucket. Java then uses equals to identify the correct object. Collisions reduce performance if they occur frequently.
What is the difference between equals and hash code?
Equals checks whether two objects are logically equal. Hash code returns an integer representing the object. If two objects are equal, their hash codes must also be equal. However, two objects may have the same hash code and still not be equal. Both methods must be overridden together for custom objects used in HashMap or HashSet.
What happens if we override equals but do not override hash code?
This is one of the most common interview questions. If you override equals but not hash code, two objects may be logically equal but produce different hash codes. HashMap and HashSet first use hash code to find the bucket. If the hash codes are different, Java places the objects into different buckets and never calls equals. As a result, duplicate objects may get stored in a HashSet or HashMap may fail to find an existing key. Always remember this rule. If you override equals, you must also override hash code.
What happens if two objects have the same hash code?
Having the same hash code does not mean the objects are equal. Both objects are stored in the same bucket. Java then uses equals to determine whether they are actually equal. If equals returns true, the existing object is used. If equals returns false, both objects are stored. So, same hash code does not always mean duplicate objects.
Can two unequal objects have the same hash code?
Yes, this situation is called a hash collision. For example, two completely different objects may accidentally generate the same hash code. Java handles this internally by storing both objects in the same bucket and comparing them using equals. Therefore, hash collisions are normal and expected.
What is comparable in Java collections?
Comparable is an interface used for natural sorting. A class implements comparable when it wants to define its default sorting order. It contains only one method. Comparator examples include sorting employees by ID or students by roll number. Collection sort automatically uses Comparator when no comparator is provided.
What is comparator in Java?
Comparator is used for custom sorting. Unlike comparable, it does not modify the original class. You can create multiple comparator implementations. For example, you can sort employees by salary, age, name, or experience without changing the employee class. Comparator provides more flexibility than comparable.
What is the difference between comparable and comparator?
Comparable defines the natural ordering of a class. Comparator defines a custom ordering. Comparable has one comparator method. Comparator has compare method. A class can implement only one comparable, but you can create multiple comparator classes for different sorting requirements. Use comparable when there is one default sorting order. Use comparator when multiple sorting options are needed.
How does collection sort work internally?
Collection sort uses TimSort internally. TimSort is a combination of merge sort and insertion sort. It performs very well for real-world data because it takes advantage of already sorted portions of the list. TimSort is stable. This means equal elements keep their original order after sorting.
What is the difference between fail-fast and fail-safe iterator?
A fail-fast iterator immediately throws concurrent modification exception if the collection is modified while iterating. Examples include ArrayList and HashMap iterators. A fail-safe iterator works on a copy of the collection. It does not throw concurrent modification exception. Examples include copy-on-write ArrayList and ConcurrentHashMap. Fail-fast detects problems quickly. Fail-safe allows safe concurrent modifications.
What is concurrent modification exception?
This exception occurs when a collection is modified while another thread or the same thread is iterating over it using a fail-fast iterator. Example, list string list equals new array list. List add for list remove. This code throws concurrent modification exception. To safely remove elements, use Iterator. Remove.
How do you safely remove elements while iterating?
Use the iterator's remove method. Example, list string list equals new array list. List add, iterator string iterator equals list iterator. While string value equals iterator next, if iterator remove. System out println. This safely removes the element without throwing concurrent modification exception.
What is iterator in Java?
Iterator is used to traverse elements one by one. It works with most collection classes. Important methods are hasNext checks whether another element exists. Next returns the next element. Remove removes the current element safely. Iterator is preferred when elements need to be removed during traversal.
What is ListIterator?
ListIterator is an advanced version of Iterator. It works only with list implementations. It can move in both forward and backward directions. It also supports add, set, and remove operations. Iterator can move only forward. ListIterator is useful when editing a list during traversal.
What is the difference between iterator and ListIterator?
Iterator works with all collection types. ListIterator works only with list. Iterator moves only forward. ListIterator moves forward and backward. Iterator cannot replace elements. ListIterator supports set to replace elements. ListIterator provides more functionality but is limited to list collections.
What is queue in Java collections?
Queue follows the first in first out principle. The first element inserted is the first one removed. Common implementations include LinkedList, PriorityQueue, and ArrayDeque. Queues are commonly used in task scheduling, message processing, and printer management.
What is PriorityQueue?
PriorityQueue stores elements according to priority rather than insertion order. By default, the smallest element has the highest priority. Example, PriorityQueue integer, Q equals new PriorityQueue, Q add, system, out, println output 10, the queue automatically returns the smallest value first.
What is Deque in Java?
Deque stands for double-ended queue. Elements can be inserted and removed from both the front and the rear. Common implementation is ArrayDeque. Deque can work as both a queue and a stack.
Why is ArrayDeque preferred over stack?
Stack is an old legacy class. ArrayDeque is faster because it has less synchronization overhead. ArrayDeque also provides better performance for stack operations like push, pop, and peek. Today, Java documentation recommends using ArrayDeque instead of stack.
What is vector in Java?
Vector is a dynamic array similar to ArrayList. The major difference is that vector is synchronized. Because of synchronization, vector is slower than ArrayList. In modern applications, ArrayList is usually preferred.
What is stack in Java?
Stack follows the last in first out principle. The last element inserted is the first one removed. Common operations include push, pop, and peek. Although stack still exists, ArrayDeque is generally recommended for stack operations because it provides better performance.
What is copy on write ArrayList?
Copy on write ArrayList is a thread-safe collection. Whenever an element is added or removed, Java creates a new copy of the internal array. Readers continue using the old array while writers work on the new one. This makes read operations very fast and safe. However, write operations are slower because copying the array takes extra time. It is best suited for applications where reads happen much more frequently than writes.
What is the difference between synchronized collections and concurrent collections?
Synchronized collections use a single lock for the entire collection. This means only one thread can access the collection at a time. Examples include collection synchronized list and collection synchronized map. Concurrent collections are designed for multiple threads. They use finer locking or lock-free techniques to improve performance. Examples include ConcurrentHashMap, copy on write ArrayList, and concurrent LinkedQueue. For multi-threaded applications, concurrent collections usually provide better performance than synchronized collections.
What is ConcurrentHashMap?
ConcurrentHashMap is a thread-safe implementation of map. Unlike Hashtable, it does not lock the entire map for every operation. Instead, multiple threads can read and update different parts of the map simultaneously. This improves performance in multi-threaded applications. Another important point is that ConcurrentHashMap does not allow null keys or null values. It is commonly used in high-performance server applications.
What is the difference between HashMap and ConcurrentHashMap?
HashMap is not thread-safe. ConcurrentHashMap is thread-safe. HashMap allows one null key and multiple null values. ConcurrentHashMap does not allow null keys or null values. HashMap is suitable for single-threaded applications. ConcurrentHashMap is designed for multi-threaded environments. If multiple threads access the same map, ConcurrentHashMap should be preferred.
What is the difference between ArrayList and vector?
Both ArrayList and vector are dynamic arrays. ArrayList is not synchronized. Vector is synchronized. Because of synchronization, vector is slower. ArrayList is preferred in modern applications. Vector is considered a legacy class and is rarely used in new projects.
What is the difference between remove and clearing collections?
Remove deletes a specific element from the collection. Clear removes every element from the collection. Example: list string, list equals new ArrayList, list add, list add, list add, list remove, system out println list clear, system out println output use remove when deleting a single element. Use clear when the entire collection should become empty.
What is the difference between size and capacity in ArrayList?
Size returns the number of elements currently stored in the ArrayList. Capacity is the size of the internal array that can store elements before resizing is needed. For example, an ArrayList may have a capacity of 10, but currently contain only 3 elements. Then, size equals 3 capacity equals 10 capacity increases automatically when more space is required. There is no direct public method to get the capacity of an ArrayList.
What is the difference between poll, remove, peek, and element in queue?
These methods behave differently when the queue is empty. Peek returns the front element without removing it. If the queue is empty, it returns null. Element also returns the front element without removing it. If the queue is empty, it throws an exception. Poll removes and returns the front element. If the queue is empty, it returns null. Remove removes and returns the front element. If the queue is empty, it throws an exception. Remember this simple rule. Peek and poll return null when the queue is empty. Element and remove throw an exception when the queue is empty.
Why is TreeMap slower than HashMap?
HashMap uses hashing to locate keys. Searching usually takes constant time. TreeMap stores keys in a red-black tree. Searching requires traversing the tree. As a result, TreeMap operations usually take logarithmic time. HashMap is faster. TreeMap should be chosen only when sorted keys are required.
Why should mutable objects not be used as HashMap keys?
A mutable object can change after it has been inserted into the HashMap. If the fields used in hash code or equals change, the hash value also changes. The object remains in its original bucket, but HashMap searches using the new hash value. As a result, the key may no longer be found. Example, class employee string id, employee this id equals id. At override public int hashcode, return id hashcode. At override public boolean equals if, return false. Employee other equals obj, return id equals. If the id field is modified after inserting the object into a HashMap, retrieving the value may fail. For this reason, immutable objects such as string are preferred as HashMap keys.
What are the most important collection framework interview tips?
Interviewers are usually checking whether you understand when and why to use each collection. Keep these points in mind. Use ArrayList when reading data is more frequent than inserting or deleting. Use LinkedList when frequent insertions and deletions are required. Use HashSet when duplicate values should not be allowed. Use TreeSet when unique elements should also remain sorted. Use HashMap for fast key value lookups. Use TreeMap when keys must stay sorted. Use ConcurrentHashMap in multi-threaded applications. Always override both equals and hashcode for custom objects used in HashMap or HashSet. Prefer ArrayDeque instead of the legacy stack class. Know the internal data structures, time complexity, and real-world use cases of each collection. These concepts are asked repeatedly in Java interviews ranging from 2 years to 15+ years of experience. So having a strong understanding of them can significantly improve your interview performance.